Alright, let's try to do some practice question together. I will want you to try 2.47, 48, and also 49. So pause the video, try it first, and we'll go through the answer together.
A few moments later.
Okay, so let's try to read the question. So it said there's mass here, and then it was released from rest, so this is U. And then when it reached the floor, it is the velocity and it will bounce back up. So then here's a graph, and obviously you should notice here is where the ball bounced from the ground, like that moment particularly, when the ball touches the ground and then it bounced back up. So it's a very short instant, of course. And it said it would be taking upward as positive. So I'll just annotate on my screen here. I assume you also do that to help yourself to be more careful throughout the whole process. So the first question is asking you the magnitude of the momentum change during the bounce. So obviously you can see that is, for part A, is finding out delta P, which is mv minus mu. And so initially it was 4 and then 0.5 for m and v. And then it would be minus also 0.5 and also u. Actually, I should do it opposite. So that should be -2 and 4 here, because -2 should be the final velocity instead. Anyway, so that should be -6 times 0.5, so -3 in total. So in terms of unit, it will be kg times meter per second. Alright, so -3. Since they are asking for magnitude, so you can actually say, and therefore, because magnitude should be like putting an absolute value on top of it. So you can say the magnitude blah 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 equals to 3 with that unit. Okay, so for part B, it says the ball stay in contact with the floor for that much of time. So that is basically delta T in your equation. Finding out the average force did the floor exert onto the ball. So obviously you'll be using the equation that we talked about earlier, which is F equals to delta P over delta T, and delta P is already found by part A, so that will be -3, or if you like to say 3, I think I'll just give it as -3, 0.15. And then you can use your calculator, which you may find the force to be -20 Newton. Okay, and one thing that you should pay attention to is that there's a diagram. Okay, so first of all, there's a diagram in the question that they provide to you, which acts as a hint. One thing that you need to understand and realize is the equation here is an idea of course, Newton's second law, like we said. So the F here, I should actually write it capital letter F. So it's actually an idea of net force. Okay, so that means the net force is -20. So that is to say, you would have the downward force that is 20 Newton. Oh, actually there's a mistake from the question. So not really mistake, but there's an issue, because it's very confusing when they say upward is positive, and then they say 4 here as positive, because by the time when the ball reaches the ground, it's going down, almost touching the ground, it's going down with 4 meters per second. So it's actually negative here. So it's actually I should put a negative here, right, and then a positive here. And so the answer should actually be +3 simply. And so here should be +3, and the answer here should be +20 Newton. So for the net force, it is 20 Newton. However, the so-called net force, actually I should change all these to capital letter F, and then that should equals to this is an upward force. So because this is the force that help you to change this velocity, which is downward to upward, right? So this has to be an upward force. So that will be R minus W, as you can see from the three-buoy diagram. So don't get confused with net force with the force exerted by the floor, because they are two different things, because there could be another force that happened, which is the weight here. So then that means the net force is 20 Newton, and then you have the reaction force here, and then the weight would then be mg, which is 5, and therefore for reaction force that will be 25 Newton, and that's 25 Newton is the answer they're looking for, which is the average force. Alright, next question. So this question tells you that there is a mass of 3 kg and it was initially at rest, and there's a graph provided to you. The first part is asking you to calculate the initial acceleration. So the graph is actually force against time. So I suppose the initial acceleration you can calculate by F equals to ma, because the force you can read here, which I think should be 12 Newton. So 12 Newton is the very early instant. That m is 3a, and so we can find out a is simply 4 meters per second squared. Very simple. For part B, it's asking you about the speed. So one thing that you can recall and relate it to this chapter, momentum, is if you look at the graph y and x here, the area is the product of x and y axis, and more physically the physical meaning of these is simply F times T, which you should have learned just now or remember from IGCSE, that is delta P, and that means the area under the line is the change of momentum, and that is 12 times a triangle, so 12 times 4 divided by 2, and delta P here is mv minus mu, while u is actually 0. So you can just calculate. So 6 times 4 is 24, and equals to mv, which is 3 times v, so v, u is 0 by the way, so v is 8 meters per second. Okay, and so c should be something that is very similar. However, you should notice that for 4 seconds to 6 seconds, the area is a negative value. In mathematics, of course, you probably were told that you can't have negative area, because I mean, if you think about our daily life, you can't have negative area. But then on a setting here, on a graph like this, you can have a negative area. So that would be the same way that you do for part B. So you can also call it as area equals to delta P, and now you have a negative value, which for the value here, I think the height here is -6. Also, actually I can just put down -6, I think, times the base, which is 2 divided by 2. So I'm just finding out the green area, and that means I have to start with the speed that I have at 4 seconds instead of the beginning. Okay, of course you can do the whole thing, but then that's another approach. So I will have mv minus mu, which, well, let me just put down -6 here, and then 3 for mass. V will be the one we want to find, and then u is the one we find, so 8 was the one that we obtained earlier. So eventually you should get -2 plus 8 equal to v, so v should equal to 6, which is slower, which makes sense because you are now kind of decelerated. As I said, the other approach that you may do as alternative for part C is to consider not from 4 seconds, you can consider it from 0 seconds. So you can skip this part if you want, but then it's always good to take a look of another approach, which at the end is still the same way. So area equal to delta P, and so the area that you find would then be the sum of 24 and -6. So 24 plus -6, and that will give you 18, and that will still be mv minus mu. However, this time the v of course is still at 6 seconds, but then the u is then 0. So you can find the same answer, which is 6 meters per second. Amazing. Alright, let's take a look at the next question. So there is a ball with a mass moving at this on a horizontal wall floor collide with the wall. So I think we can draw a diagram like this. Alright, it's always good to draw a diagram. So going with 3.6, okay, and collide, rebounds at 3.2. So some kinetic energy is lost, I suppose. The contact time delta t is known, right? Millisecond. Maximum force. Okay, so if the force vary according to this graph. Alright, this is useful later on. The first thing that you may recall is again the equation of F equals to delta P over delta T. And so then you may find delta P will then be mv minus mu. So mv minus u over the delta T. So according to the numbers that we have in the question, 0.2, v is 3.2. Depending on which direction you want to take, you can do positive for the left hand side, and then this would then be negative. So that will be minus a negative 3.6 divided by the time, which is 12 over 1000. So then you can use your calculator and find the answer, which should be 113.3 recurrent Newton. So I should run it up to, I think, 2 sig fic. So 110 Newton. Alright, but then actually, actually this is not even the final answer, because they are asking us to find the maximum force. So the equation here that you are using is finding out the average only, right? Because imagine this, what you do is you are trying to finding out the area under the line, which is so-called the impulse delta P. And then if you think about trying to rearrange this equation, which is actually the last equation of your data booklet, right? This is what it is, right? F times delta T. So what you actually are doing here is trying to find the so-called average value of the F, right? This is the so-called F that you're finding, which is 113.3 Newton. All right, and imagine the force is just being a constant force that being exerted in this 12 milliseconds. But of course, in reality, it doesn't. All right, even in reality, it shouldn't be like a linear force like this. Probably it's more like a smooth curve instead. So this is just an estimation, all right, or you try to model it only. So other than using this to model, we can use a triangle to model. So we want to actually find this, all right, the tip of the triangle. So that means what we could do instead is actually the answer is actually times 2. But then to show you more properly, I probably should do actually I should do F. Yeah, I should do F max, and then this is delta T, right? So actually is if you think about the area, that is F max times delta T equals to delta P. So divide by 2, right? Because it's a triangle. So then delta P is actually found. Actually, F max divided by 2 equals to delta P over delta T, which is the one that we just find, which is 113.3 3.3, right? So I hope you understand why I said just now the answer is simply times 2, because if you look at this one and this one, then you can see F max would then be 226.6. So then if you run it up to sig fig, then that should be 230 Newton. So that will be the final answer, and that means the maximum force experience will be around 230 Newton.